Plumbers videos. My name's Alan Hart, and in today's video we've got some special guests today. We've got Elliot back from E-Fry Gas Services, who's going to give us a few tips for trainees, really, a few tips for you. We've also got Kevin back, who is the ex-Ideal engineer, and Kevin's going to talk to us about pumps in a boiler, which is really interesting. So yeah, without further ado, let's go over to this video.
Club. On this one, boilers down there, and you can see it. Vertical flow, really long flow. It was actually a Ferroli Optimax 38 kilowatt in here. Completely unneeded, it's 2-bed semi. But the flue is really long. Goes right up past Adam there, out for the wall where Adam's just making good. On this one, just a heads up, those of you that don't know, and if you use glowworm or Valent boilers, we've got a 1 metre length here, just off the back of these 245s. But where you can see the joint there, that is then a 4 metre, sorry, no, here. From here, right up to the terminal length, there's a 4 metre long straight run. That clamp there is just, it's like a factory made joint, so it's just there to give a bit of brace. But it's a 4 metre long length run, and it makes it so much easier when you're in a long loft space, rather than doing a million joints and worrying about a million flue joints and filing them and cutting them and whatever you need to do. It's just one big long length. So hopefully that comes in useful to a few people. But yeah, it does make it a lot easier, especially for us today in this loft space, because it's not, I mean, look at Adam's really squished up at the end there. But yeah, it does come in really useful. So 4 metre long flue length, and they do a 1.7 metre terminal length as well, which gets you out of a few tight spots. But yeah, quite cool really to get it in. And we had a bit of an awkward time on this one. Got to fit a 5-stop plate there because the old flue was a completely different position, but yeah, but making good. But yeah, just a heads up really. Just a quick little helpful one, hopefully for a few people. When you're taking out a boiler, this is the apprentices and learners, get some 3/4 caps, some 1/2-inch caps, because some boilers just hold water, and the minute you lift them off the wall, you're guaranteed to pee water all over their carpets or something. And if it's a condensing boiler you're taking out, don't forget, the trap will probably still have some water in it. Either take the trap out if you can. If you can't, stuff something in the hose, and it'll stop you either wetting all over yourself or wetting over the customer's carpet. Cheers. So I'm just servicing this Potterton system boiler. This little video is just to help people out reading data badges, what some of it means. On this particular model, the reason I'm doing this video is because I've been asked many times by trainees and a few qualified people actually, but data badges, so we can ignore the hot water taps because this isn't a combi. We've got QN in kilowatt, we've got PN and PN, and the two PNs give different numbers, 50-30 and 80-60, and a range of figures, which is kilowatts. How do we know which one is what we're looking for in a gas rating? First of all, when you gas rate, hopefully you're very close to one of these figures. What we're looking for is this really easy way to tell which is the ones you want to pay attention to and what your kilowatt rating should be. If you forget, it's called using the booklet. Okay, Alan and all the other guys that give little videos for Alan, including myself, we're not trainers, but we're trying to help out and raise the standards. So grab the booklet. All right, this one's online. Heat input QN gross. QN, there it is. On this particular model, it's 27.4. And when you go down to QN, in gross, 24 model, which this is, should be 27.4. It tells you in the booklet. The other ones here, so we've got PN and PN, 24.7, 25.9. PN in non-condensing mode, 24.7, 24.7, PN 80-60, and then PN 50-30, 25.9 is heat output condensing, 25.9, there we go. So hopefully that helps a few people out. It is all there, the information's in the booklets. If you don't know how to read these properly, I mean, they're not overly complex, but they can get a few people when you get like this, type C13, C33, C53. Guess what? It's in the boiler booklet. And when you do your gas exams, you should know what C13, C33, C53 and all the others are, depending on what exams you're sitting. But yeah, obviously NOx classes and things like that. But all this information, sometimes it won't say certain bits, and you'll be like, which one is it? It will just give you 3 different symbols of a tap and maybe a PN, maybe not. But have a look in the booklet. It makes things a lot easier. Hope that's helpful. quick little video. Cheers.
Thank you very much for that, Elliot. I personally didn't even know you could buy a flue that's 4 meters long, so that's very interesting. So yeah, thanks for that. Let's go over to see Kevin, the ex-Ideal engineer.
So, good morning, YouTube. It is me again with another video, but I thought this time I'd do something slightly different. I think I mentioned in my last video that I'd done pretty much every part of the boiler. I've covered every part, but then I realized I hadn't spoke about the pump, and so I thought I'd give you a bit of a talk on the pump today. It's going to be different because the pump, an ERP pump, for instance, has two inputs. It has the 240 volt supply on this connection here, which supplies a circuit board. There's a circuit board inside this pump here. There's a circuit board in there, and the 240 volts is the permanent supply to power the circuit board. And this connection here is the 5 volt DC supply, which is the PWM, pulse width modulation, and that drives the pump. That actually rotates, and well, that drives the pump pretty much. It's the same. It's pretty much the same principle as the fan. It has the Hall sensor inside, and it senses a magnetic field from the magnets, and you know, sends a pulse back to the circuit board directly proportional to the rotation of the pump. So I'm not going to go into that because I've covered it in the fan video. So you know, it works it works pretty much the same. So if you want to know how that works, probably watch the fan video. I'm not going to go over the information again. And because it's got a circuit board in, you can't get a readable resistance off it. So with a normal standard system pump, or I mean an old combination boiler pump, either you can get a readable resistance. You can measure the windings in it, and off the top of my head, roughly, you'd have to quote manufacturer, but they're around about 150 to 180 ohms, give or take. But yeah, that's not important. So you can't test the resistance of the pump because it's got a circuit board in, and if you look on the back, it's got loads of coils in it. It's got lots of different coils in, so there's no real way electronically you can test for, you know, the efficacy of the pump. So there's not really any real good test you can check to see if it's functioning properly, but you know, you can make sure there's power there, and you can probably check a signal back. But I'm not going to talk about that. I'm going to talk about a problem you might get with these pumps. Problem I've had a lot of the time in the past, and it's to do with tripping an RCD. What happens with these pumps when you first power them up? They draw a lot of current. They do draw a lot of current on first power up, and what can happen at some stage, if you've got a weak RCD, it'll trip the RCD, and then people will think there's a problem with the boiler. And I want to talk about that really, because it's quite a common problem. I had it quite a lot of in my days at Ideal, and even, I mean, the times I've had it, a couple of times one was in an electrician's house who told me that he checked everything, and he put it down to the boiler, and after me doing some investigation where I found out it was the RCD. A second time, electrician was actually stripping the kitchen of the wiring. He had all the sockets up. He was rewiring the kitchen, and I came on site with him. I said, have you checked the RCD? And he said, no, it's brand new RCD. I said, well, okay, well, have you checked it? They said, no, it's a brand new RCD. And I said, okay, well, can I check it then? And he come to the conclusion. He got his mega out and put current through it and realised the RCD was tripping at like 15 milliamps rather. I think an RCD trips at about 30 milliamps. So, I mean, if you're going to a boiler with an ERP pump and you're tripping the RCD as soon as you turn the power onto the boiler, obviously do your short circuit tests and what have you. And then disconnect the 240 volt power supply to the pump and the fan, because they both run off 240 volts. But it's generally the pump that's causing it to trip. Disconnect it and then power it up. And if it stays on, it's probably the pump, you know, drawing a lot of current. And there's not a lot of ways you can use this kind of equipment. You can use your voltage tester, multimeter, socket, and see. But there's not a lot you can do to confirm how if the pump is drawing a lot of current and the RCD is weak, other than using one of these. So what I did when I first found the problem on the electrician's house, I realised he had two RCDs, one for upstairs and one for downstairs, and the boiler was upstairs. So it was just tripping the upstairs RCD. So I ran an extension lead downstairs to a socket, ran the extension lead all the way up the stairs, disconnected the boiler mains incoming power from the fuse spur, and I wired this plug-in to the boiler, plugged it into my extension lead, turned it on, and the boiler ran, it fired. So then I told the electrician, he was there for the first time, you know, I was like plugging new pumps in, I wasn't changing the pump, I was just getting a pump out my van and plugging it in and seeing what happened. And then obviously I did my short circuit test and I realised there's nothing wrong with this boiler. So then I figured out, you know, run the extension lead and plug this in. So then I told the electrician it's your RCD and he weren't very happy with me. But it was his RCD. And then the second time when I went to the electrician, he was a bit embarrassed because he hadn't checked it. I'm not bagging on electricians because I'm not trying to say. I've had this with heating engineers too, and he's fitted a brand new Vogue and he's just turned it on and he's called us out under warranty, and I've just said to him, I just showed him what to do. I just ran an extension lead. I've even ran an extension lead into the next door neighbour's house because they were only on one RCD. One RCD controlling the whole fuse board. So I've actually knocked on the door next door, ran an extension lead, disconnected the power from the boiler and plugged the boiler in. And that's, unless you've got a mega like which an electrician has, and you can put current through the RCD to trip it, and then measure. I mean, you can trip it with one of them, but you won't tell you if it's tripping at 30 milliamps or what have you. So it's just a bit of a tip, really. This video, this video isn't to tell you how to test a pump, because these pumps, you can't really test them, to be fair. There's no real test. I mean, I think if I remember rightly, this is a UPM. The UPS is the system pump, and I think when they first came out, you had to wire in a suppressor to, you know, because of the same issue. It was tripping the RCD. So I think they probably overcome that problem now. But this is just a little tip, and this won't just be for ideal boilers. This will be for Wiesmann, Valen, Worcester. I mean, anyone that uses a Grundfos ERP pump, Baxi, whoever you want to call, they've probably had issues with this too. Just it's drawing the current, and if you've got a weak RCD, it'll trip it. And the best way to determine whether the RCD is weak is disconnect it from the RCD. Keep yourself a bit of a fly lead on your van and run an extension lead to a different power source, and then power in the boiler, and you'll probably find 9 times out of 10 it's the RCD and not the pump. So I hope that helps. It's just a little tip, this one, and I've got a couple more videos in mind that I might want to try and do. Something a little bit different, system wiring and stuff like that, if anyone's interested. Like I said, I'm bored. So anybody who wants any videos making, just let me know and I'll see if I can do them for you. Okay, thank you. Bye-bye.
Thank you very much for that, Kevin and Elliot. It's really appreciated. If you've got any questions, please add some comments below. And if you've got any videos that you want to send in, I will have my WhatsApp in the comments below, and you can send me any videos you like, and if I can put them into a video, I will try and do that. Yeah, thanks very much. Thanks for watching.